Maybe. We'll find out. Okay,
So,
I have the quiz up whenever, or I'm good. Sorry, guys, my brain's all over the place right now.
okay.
Okay. Give me just a moment.
Okay.
I loaded up my email, got this going. I still need to finish getting into all the stuff here. Just a moment.
But I'm so shocked that he left. So we need to think about the next presentation, right?
Yeah, we have to figure that out.
Okay.
So with that, we can all just like work on it together. We'll figure it out.
Yeah.
So this is lesson 21, right?
Correct. 22.
22.
22.
Gotcha. Why did it pull up to 21?
Maybe you're still sleeping.
I probably am.
But
okay,
it's still bright. Idaho is still bright outside. Texas is dark outside. Yeah, almost 8. Yeah, no wonder. Okay.
Okay, almost got it. I'm sorry about that.
No problem. So my family is crazy now. fighting, screaming and yelling.
Okay, start quiz. All right, I'm in.
Okay. Question 3. This one is easier, right?
Yeah.
Ready?
Yep. So given the linear regression equation y equals 2 plus 1.5x, what is the y-intercept? That would be 2.
So round to 1 decimal is no point?
Well, you could do 2.1 or 2.0.
Okay.
What I meant to say.
Okay. I don't know what this meant. In case.
Yeah,
okay.
in case.
So Robbie, got it? Can we move?
Yeah.
Okay. Question 4. So what the slope?
It wants to know what the slope is. So 1.5.
Right.
Yes. And
so
question 5.
Given the linear
regression.
Right? Yeah. So y equals negative 3 plus 0.25x. What is the predicted value of y when x is 16? So you just calculate it.
So that'd be 1.
1 or 1.0. Which one? 1? Either one, right?
1.0.
Okay. And question 6. Hamburger. No. Yeah.
So wait, you guys got 1 for question 5?
I put 1.0.
Okay.
Because that would be
either one,
16
right?
times 0.25. So basically it's a quarter of that. So it's 4. And then it'd be negative 3 plus 4. So
1. Okay, gotcha.
1. Because round to 1. I don't know. Okay. So next we open Excel sheet and copy and paste. So
into the linear regression, right?
Yeah, be sure to use the confidence data for the explanatory variable and the score data as the responsible variable. Is it correct? Variable.
Yeah, so the confidence is going to be X.
So, and I think I did
Normally my Excel sheets are generally always up, but I had to restart my computer the other day and I lost them. So let me get that back. So it's the quantitative inferential one we need for this?
Yeah, the same one we used on Monday.
T-test.
Okay.
It's quantitative inference procedures.
Okay. Well, I was thinking about loading. Sorry about this. So you're saying that this was going to be a hamburger?
It's going to be hot dog.
Yeah. Mine's a hamburger. I know it's not banana. Banana shape is like this, right? Hot dog is...
Mine looks more hot dog than hamburger.
Really? Like
because mine goes like it's not like all over the place. It's more like
mine's like this. Can you see
so
that?
that looks more probably hot dog because it is more.
It is?
Yeah.
It's just same?
Yeah, like mine looks like that too.
It has more
okay.
Mine.
So hot dog. Okay. So if I say hamburger is more separate?
Yeah, hamburger's not. So you see with this one, it has a clear, like it's going up. Like there's a clear. I don't know
see.
the word
Hamburger is more like kind of like this shape. Hamburger.
Yeah, it's more like rounded. There's not a definite like progression with them. Just kind of all over the place.
Got it. So hot dog. Got it.
Yeah.
Okay, question 7.
Says, based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model these data?
Conduct significant. So it text set. What text says?
I would say the second one.
Second one, yeah.
How many observations are in this data?
So I don't know. How can we find it?
Well,
just to check the data?
Yeah. So 142 is where it ends.
So 139?
Yeah.
Just like a sample size?
Yeah.
Kind of? Oh, okay. 139.
Yeah, I wonder if there is a sample.
So if we check the data, we can find the number, right?
Huh?
So like we cannot find a number from this here, right? Just check here.
I don't think so. You have to check the Excel.
Okay. Got it. So Robbie?
Yeah.
Robbie? Okay. So question 9.
That Excel sheet still.
Oh, okay.
Yeah, I got like our normal the quantitative inferential spreadsheet up. I just okay, and there's the math self-efficiency. Okay. Finally got that. And yeah,
So
definitely looking more hot dog. And so the observations is basically
question 7. Yes, middle if samples.
so that's just the total number of samples. And so we determined, you said like 130 something?
139.
139.
Okay, question 9. My answer is 18.690.
That's what I got.
Okay, good.
Does
How about
it list that in y-intercept?
It's in the Excel.
You got 18?
Yeah, we're
Okay. Here.
So it's in the, I guess in like that second row, how it lists the y-intercept, right?
Yeah, here. And here. Okay.
Right.
Then
so
next
it's like
is
so you see where it says model and then it says y-intercept slope, and then over it says b 18.690.
Okay, I'm just looking in. Yeah, mine's showing 1.296.
Did you put your
yeah, mine's right.
so your comp so the thank you people.
You
So your confidence mean should be your X, not your score.
The confidence mean?
Yeah.
so for
So the second row of like data should be the X in the Excel that you put it in.
ここだけ使ってくれる？ママ使い
Okay,
たら
now
どう
mine's currently showing underneath X is 6. So what should I put there instead? I'll get that other blue highlighted spot.
No. Okay, so look,
What?
go to your Excel sheet, like your math self-efficiency sheet.
Oh, okay.
So your confidence mean, you see that? So it says gender score, confidence rating mean.
Yes.
All of that data is your X.
Yeah, 4.34, you know, kind of.
So that all goes in first.
Okay, gotcha.
And then the other one is your Y. So it's backwards. You have to switch them. You can't just copy and paste them the same.
Gotcha. So I need to flip the data. Okay. So delete this. First copy the score. So it's that in the Y.
18.690.
And then
question 10 is
mean. The confidence rating mean is the X value. Put that in the left.
what?
Copy.
Are you talking about question 10?
Okay, here he goes. The 18.690. That's what you said you got, right?
Yes.
Correct.
So question 9 and the question 10 is 12.695. Slope. Headache. Okay?
12.695. Okay, I'm with you.
Okay, and the question 11. My answer is 69.470. No, because I just calculate 80.69 plus 12.695 device.
So
well, 4.
All you
No?
have to do, so go to your Excel sheet, and
Mhm.
in there where it says confidence and prediction intervals, there's an X, and
Wait
you
a
can
minute.
change
Yeah.
that.
6?
You change it to whatever they give you X. So you just change that to 4,
Ah.
and it does all the math for you.
Don't you love Excel?
Uh, What's going on?
So where it says 6, you say 4, and then it says predicted. So my predicted is 69.469.
Wait a minute. I didn't know that. So put 4, right?
Yeah, put 4 instead of 6 because that's your new X.
And where to check the answer?
Right
Predicted?
next to it where it says predicted.
Okay. Oh, thank you. How
Yeah.
did you know that?
I don't know.
I watched the video. I couldn't find that. Oh, wow. Thank you. Okay, 12. So 12, 13, 14, and I don't know.
The confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of Y for these value hints? Because there is a positive correlation, we can use the largest X value to find the largest predictor of Y.
What? Because there is a positive correlation. Largest X value to find. Largest?
So can we just sort the data by
scale of
size?
1 to 6? Question 1 to 6. Question 1 to 6. Maximum. One to 6 maximum? 1 to 6?
Where do you see that?
Question 13, I don't know. 14, I don't know. 15, I don't know. So, okay. Savannah, question 13, you got it?
I am looking.
Okay. But text didn't say about that.
We use the highest.
Okay.
The highest X to find the highest Y. Use the largest X value to find the largest predicted value of Y.
This is a hint. Question 1 to 6, right? 1 to 6. Confidence. What? Result from students. Each question was variable Y.
These numbers are not sorted by
something formula. We have a formula.
Okay, so I'm pretty sure you just change X back to 6 because that's the highest it can be is 6 because it says it's on a scale of 1 to 6. And then it says, and then we have the prediction interval for Y. So then I think it would just be the 117.445 because that's our maximum data. That's our confidence interval. So we have the max and the min in those intervals. And so if we change the X back to 6,
okay, so
the highest it can be for the prediction interval.
Well, except problem with that is technically with the isn't the highest it could be on this 100?
No, because it says it's on a scale of 1 to 6. So your X values have to be between 1 and 6.
Right, so the X value, but the Y value, because how it's rating the scores on a test. And so the highest it could be is 100%. They got a perfect score on the test. So how?
The hint is not hint.
It's a weird question.
Because there is a positive.
Maximum predicted value of y.
The video said if the number is negative, he said something.
I don't know. I don't have any other ideas, so I'm willing to try 117. And if we get it wrong, then we can come up with something else. But I mean, I don't have any other ideas, so there's no reason to.
That doesn't sound like what it is going for. It's just weird.
I understand what you're saying. Like, how can you get more than 100 on a test? But
yeah, but that's where that's the maximum predicted value.
Yeah. Anyway.
117.445.
Okay.
And I'll submit, and if we get it wrong, then how many explanatory independent variables are present in a simple linear regression?
So what's that mean? How to find? I know the independent is x something. X how many?
Simple linear.
1. More than 2 or 1 or 2.
I almost want to say 2 just because it's. No, just kidding. It's only 1. I'm looking at the summary in the textbook. How it says the independent or explanatory variable is x, is a variable which is not affected by what happens to the other variable. The dependent is the variable which is affected by what happens to the other variable.
Okay.
So it's 1. It's just the x.
And then dependent is 2?
It's a y.
Well, that should also just be 1 because that's the y value.
X, y. Okay.
A company in South Dakota manufactures hard hats used in mining industry. They record measurements on all the hats they produce for their quality control and planning purposes. The measurements they collect include the hat size, circumference of the hat, and length of the major and minor axes, meaning the company wants to predict size of the hat given the circumference. What is the response variable? I think it would be the size of the hat because it's being used to predict the circumference. Or would it be the circumference?
Yeah, but the correct includes hat size, circumference.
So in our project, our response variable is like the total fat and all of those things, the things we are comparing. So in this, the response variable would be...
Because they are trying to find...
They're trying to predict the size of the hat given the circumference. So wouldn't it be the third one?
The size of the hat. Well, because it's
being used to,
or be the first one because that is a variable being predicted. Because they're not trying to predict circumference; they're trying to predict the size of the hat.
Oh, that's true. Okay, yeah, you're right.
Number 1.
Will submit, and I will see how we did.
You said first one?
Yeah.
We got an 88.
Okay.
Which one did we miss?
We missed 12.
12.
And
10,
7.
11. And 7?
Yeah.
Let's see, what was 7?
7? 12 and 7.
Yeah, 7.
Okay.
So I'm just probably thinking simple linear regression is appropriate for these data.
Probably.
I'll go ahead and try and put in just like
Because it's
100 for question 12 and see if that gets it.
Okay, sounds good.
because a hot
Go to submit quiz.
hot dog, right? There is a significant line of relationship. Hold on. There's a simple and separate.
So 7, it is simple linear regression is appropriate for this data. And got
First
number
one.
12 wrong again. It's not 100.
Okay,
So question 7 is
the first one.
okay.
Well, maybe we can. I don't know.
Think
I'll
about
do some-
later.
Yeah, I don't. I have zero idea how to figure 12 out. So
Me either.
Based on what we have.
yeah.